Space is not empty.
What do we do?
When tiny shards of metal,
Fill the orbit of Earth.
how do we explore?
Where do we go?
At AeroTec, it is our duty to protect humanity from the threat of space debris.
Hi, I am Yolanda, the Chief Executive Officer and the Chief Financial Officer at AeroTec.
Hi, I'm David, the Chief Tech Officer and Chief Operating Officer of AeroTec. Here is AeroTec's latest product, AeroShield. We believe that these panels of aerogel, manufactured in space, are the solution to orbital debris.
As space exploration shifts from government research to commercial spaceflight, the number of satellites and space stations launched into low Earth orbit is increasing exponentially. The surge in the number of objects orbiting around the Earth increases the likelihood of collision between functioning artificial objects and orbital debris, or space junk, traveling around the Earth at more than 7 kilometers per second. Although orbital debris of 10 centimeters in diameter or larger can be tracked by modern technology, it is impossible for the system to track the millions more debris with a size just around 1 centimeter in diameter. These invisible debris pose great threats to space stations and satellites in low Earth orbit due to the tremendous energy they carry in their orbit. Research on Earth has proven that a steel ball of merely 5 millimeters diameter is capable of penetrating a 1 centimeter thick aluminum plate and leaving the damage the size of a bullet hole. Such an impact on any functioning commercial space station in space is enough to cause deep compression in the module and threaten the safety of the crew on board. To combat this increasing danger of collision, we at AeroTec devised the AeroShield to provide protection to space stations from colliding with the invisible bullets in low Earth orbit.
So, how does AeroShield work? AeroShields are panels of aerogel manufactured in space. Combined with a nylon layer to maintain structural integrity, the AeroShield can resist the impact of particles traveling at more than 25,000 km per hour. A lot of the magic of AeroShield comes from aerogel, a solid structure that is formed by removing the solvents from a gel material. As the world's lightest solid, aerogel can resist hypervelocity impact, extremely high temperatures, and electromagnetic radiations. NASA deployed aerogel in its Stardust missions to capture cosmic dust, and the AeroShield uses a very similar idea to capture the fast-traveling orbital debris and prevent their damage to spacecraft. At the same time, the AeroShield cleans up orbital debris by capturing them and removing them from orbit. Now here's a question. How do we get the AeroShield into orbit? Despite the excellent properties of aerogel, they are also brittle and large. It would be highly inefficient to directly send them to orbit using transport vehicles. But worry not, here's our solution. Meet AMM, AeroShield Manufacturing Module. It allows us to directly manufacture AeroShield in space, utilizing its cold, low-gravity vacuum environment. In addition, AMM stores the materials compactly in the forms of rolls of nylon and tanks of gel. Inside the AMM, AeroShield is printed onto the nylon sheet, and together they move through the 1.5 meter long nozzle that connects the pressurized internals to space. The liquid gradually flows into a solid as it went through the nozzle, and the panels are then placed under the sun to cause the solvent to sublime, completing the freeze-drying process. The overall result is an automatic factory in space that produces aerogel in the scale impossible to achieve on Earth. The process of delivering our product service to a client has 4 steps. First, we will work closely with our client's team to plan and design how the AeroShield will be installed. This includes planning out the placement of each of the individual AeroShield pieces and their custom mounting structures. Next, we will send our manufacturing module to our client's orbital location. We will work with the astronauts on board to ensure the successful installation of the AMM and AeroShield. After all the installation is complete, we will continue to provide service and support to protect our client's spacecraft. This long-term service includes replenishing and replacing the AeroShields and optimizations around the protection.
There are currently 3 government-funded orbital debris cleaning projects under development. All 3 of the projects target the removal of large orbital debris, usually defunct satellites. AeroShield, on the other hand, mitigates orbital debris that are of smaller sizes but are still capable of creating severe damage due to their invisibility to the tracking system. As the first project to directly construct aerogel panels in low Earth orbit, the unique manufacturing process for the AeroShield significantly lowers the cost of aerogel by utilizing the advantages of the space environment. AeroShield also introduces essential technology to the world of 3D printing, like maintaining constant pressure inside the manufacturing module as the nozzle pushes out the frozen aerogel. Our timeline is divided into 3 stages. The first stage is to develop and implement prototypes of the AeroShield on the ISS. We will use NASA's Student Spaceflight Experiment Program, the SSEP, as an opportunity to help us test the behavior of aerogel in the microgravity environment. It will also serve as an important connection between our company and NASA. The intermediary stage between 2022 and 2024 is to develop the manufacturing module of the AeroShield. We will collaborate with experts from NASA to help us refine the design and test a prototype. Then, we will launch the manufacturing module and start producing AeroShield on the ISS. After testing on the ISS proves to be successful, we will commercialize the AeroShield and sell the product to potential customers who are interested in shielding their spacecraft from orbital debris. We will gain publicity through advertisements. Our third stage looks out to the future of human space exploration. This is where aerogel's other properties such as thermal insulation and radiation protection come into play. Variations of the AeroShield can be implemented on lunar and Martian habitats to protect astronauts from dust storms, radiations, and temperature changes. Our goal is to assist humanity in the process of developing a spacefaring civilization with interplanetary colonies. We will also be looking at ways to minimize the manufacturing cost of aerogel on Earth and make it easier to implement aerogel insulation in face of extreme weathers.
We will gather funding for the first stage of our project, which is approximately $80,000, from student grants like Skydeck and small business loans. As we develop a partnership with NASA and enter the development stage for the manufacturing module, our funding will mainly rely on government contracts, with crowdfunding, venture capital, and business loans to support extra financial investment. Here is a table of the overall estimated cost for the 2 stages of our project. It is estimated that we will be profiting the 3rd year after AeroShield is commercialized.
With AeroTec, we sail deeper in space,
We enjoy space traveling.
find solutions for climate change.
We protect the future of humanity.
This is AeroShield.
And we are AeroTec.